that this is, if we look at the average variable cost, this is the blue line. The marginal cost comes up and intersects that at its minimum, and we come up to the average total cost, the green line, and once again, the marginal cost intersects the average total cost at its minimum. Why is that true? Yes?
Because the marginal line variable cost is given, so we put that marginal return, and so as marginal returns increase, variable costs increase. So marginal costs like each one increasing, and so as the average variable costs decrease and increase, we're getting to a marginal, giving that minimum marginal, getting to marginal cost where.
Yeah, okay, let's try it a different way. I think you were on the right track, but there were too many words, right? Think about it the following way. If the marginal cost is below the average total cost, will the average total cost be falling or rising? And stop for a moment and think about something that you're all familiar with. Think about your GPA, right? Let's suppose that you have an average GPA as this semester began. And we all know that you're going to do superbly well in this class, so you're going to get a grade that's going to raise your GPA, right? Well, I want to go to the opposite example. Let's take the other example first. Let's suppose the next course that you take, forget about this course, I don't want to make it personal. Suppose that your grade is below your average GPA. What's going to happen to your average GPA as you add that incremental grade? Pardon? It'll drop, right? It'll drop. And, moreover, if it turns out your next grade is above your average GPA, what's going to happen? It's going to go up. So that's what we're seeing in this particular graph here. What's happening is that this average total cost continues to fall as long as the marginal cost is below it, right? But as soon as it gets to its minimum, the marginal cost is above, so now it's going to raise the average total cost. And it's going to do exactly the same thing with regard to the average variable cost, right? Yes?
So it also looks like the average fixed cost intersects the marginal cost, but isn't it?
Say again, the average what? No, it doesn't. The average fixed cost is steadily declining from that point forward. That's not the minimum on the average fixed cost. No, there's no relationship there, necessarily. Yeah, that's the numbers here. There's no reason. You can check that afterwards. In fact, we can prove it mathematically. There's no reason for that, but there is a dramatic reason for why this point here intersects at the minimum on the average variable cost and at the average total cost. Suppose the marginal cost steadily declined throughout all output levels. What would happen to your average total cost? Continue to decline, right? And some people would argue that that's what happens in the pharmaceutical industry, and some people would argue that's what happens in the software industry. And we'll look at some of those examples down the road after we get the basic facts right, the basic relationships right. Okay, here's an active learning result. If I give you the information there, I'm representing to you that based on everything that we've discussed up until now, you can fill out the rest of this table. What I want you to do is visit with your neighbors and start filling out the table. Don't you fall asleep on me? I'm teasing you, I'm teasing you. Yes? I did there. Yeah, I did there because it's discrete, right? If you had a continuous curve, you would actually plot it right at the point. Yeah, there's no mystery about that. Yes, yeah. We get it all filled out? Yeah, there's a lot of different equations that have to be used, but every one of those equations I've already given you. But you have to work with about 6 or 7 equations to fill it out.
I was just about to run through it. I have to start actually stating that.
Okay, we ready for the answers? Gabe, got your hand up or are you just stretching? Okay. You were answering my question?
Yeah, I'm sorry, yes.
Okay, go ahead. Yes?
All of them?
Let's take the first half.
All right.
I'm sorry.
So the average variable cost of top left box is 0.
Explain why in each case. You're right, but why?
So you can tell between variable and total at quantity 2 that 50 and again 4 is 50. And so the definition of fixed cost doesn't change based on quantity. Also, when you have zero quantity, you can't have any variable cost. You don't have to do anything yet. So things like materials, there are no zero yet. So any cost at that point is going to be fixed. So your total cost is just fixed, so the variable is 0. Sorry, is that right?
Yeah.
All right. The second box is 60, so it's your $10 variable plus $6 fixed. The third box is 50 because it's your fixed cost divided by quantity, 6 divided by 1, and that's 50.
Everybody sees where he's going, right? It all makes sense. He's got it right. Let's fill it out along the lines of what Gabe just said. So the first, you can deduce that the fixed cost is 50 using the fact that fixed cost plus variable cost must be equal to total cost, right? And then you just go through the process. You fill that out, You fill out the total cost here of 60 once you know the fixed cost is 50. And moreover, you can get down to the quantity of 5, and you know what the total cost there is, given that you know variable cost is 150, and you've already determined the fixed cost is 50. Okay, and you proceed sequentially just like this. The next relationship you need is the average fixed cost, which you know is fixed cost divided by quantity. And for quantity of 1, clearly the average fixed cost is 50, given that the total fixed cost is 50. Right? And you continue in this fashion, filling out what you can based on that relationship. Then you turn to the average variable cost, and you look at the boxes where you have enough information to report the average variable cost, and that occurs for an output of 2. For an average variable cost of 15, you can also make that determination for a quantity of 4, and you get the average variable cost of 25. And you can do the same thing with regard to once you have the average variable cost and you know what the quantity of output is, you can compute the total variable cost. Right? Whoops. Sorry. And then the final few is using the relationship between marginal cost and total cost. You can compute some of the missing cells for the marginal cost, which I've done in the final column here. 3 of those missing cells can be filled in. And finally, the average total cost is equal to total cost divided by quantity. And the missing cell that we have here, we can fill that one in, and we can also fill this one in. And we're done. Voila. It's fairly straightforward, right? As long as you have all those relationships in mind, if you're given this kind of information, you can determine what are, based on those relationships, the missing information. Okay? Now, why is the average total cost U-shaped? Falling for lower levels of output, reaching a minimum, and then beginning to rise. And moreover, as a general definition, an efficient scale is the quantity that minimizes the average total cost. So the efficient scale for this numerical example is for a quantity of output of 5, because that's where the average total cost is minimized. And moreover, we've already established that the marginal cost must intersect the average total cost curve at the minimum of the average total cost curve, and we've already specified the reasons for why that's true, using our example of grade point average, or just thinking about the relationship between an average and an increment, or a marginal change in that numerical calculation. Cost in the short run versus the long run, the flexibility question. Okay? Right. Okay, short run versus long run. As we indicated, in the very short run, factories, land, etc., many of the inputs are fixed and can't be changed. There are other inputs that are variable in the short run, but in the very long run, all inputs are variable. You can change the scale of the factories, where they're located, and given that flexibility, what information is revealed by the average total cost? And let's look at an example where we've got 3 factory sizes. If we're in the short run, one of those factory sizes has been selected, and we've got an average total cost curve for that factory. But we may not have a small factory, we may have a large factory in the short run or a medium factory. So we're going to look at 3 different factory average total cost curves. And we'll label this as a factory size that's small, S, a factory size that's medium, M, or a large factory size. And each of these factories has an average total cost of operation, which is its short-run average total cost curve. And this would be the average total cost curve for a small factory. For a medium-sized factory, this would be the average total cost curve. And for a large factory size, this would be the average total cost. Right? Now, when I look at the very long run, and I can make a choice about any one of these factories to establish the scale of my operation, and if I look at which, in the long run, which of these factory sizes would I select? If it turns out that the quantity that I'm going to produce, and I need other information to decide what quantity I'm going to produce, but let's suppose that I've predetermined that I'm going to produce less than QA. Which factory size should I select? Pardon? Small. And why would I select small? Isn't it crystal clear why would I select small? Well, for all the quantities I'm producing here, most economies of scale or the lowest cost, right? The lowest cost for those quantities. However, if I wanted to produce some quantity greater than QA up to QB, if the market tells me that's the optimal quantity, and I haven't given you the basis for making that choice, we're just looking at hypothetical situations where you selected that particular quantity, and for that quantity, you're going to end up selecting a medium-sized factory, right? And if it turns out you want to produce some quantity above QB, then it would be in your best interest to select the large factory, because it would have the lowest cost among those 3 factory sizes for that particular quantity, right? As a result, these are all short-run average total cost curves, but we can take and look at the long-run curve, which is represented now as the tangent to those costs where those are minimum cost factories, and which ones dominate, and that then becomes our long-run average total cost. Now, here we're only looking at 3 factory sizes. Suppose we looked at a whole bunch of them. That long-run average cost curve would then become smooth, right? And this now would be our long-run average cost curve, which would be the envelope of all of those short-run average total cost curves represented by the red curve, right? And that would be, for different levels of output, that would be, or give me information about the factory size that I would want to select if I economically decided that that was the best output to produce and offer to the marketplace. Now, how does the long-run average total cost curves change as production changes? Economies of scale. The economies of scale, average total cost falls as quantity increases. That's economies of scale. Constant returns to scale is when the average total cost is constant as there's changes in quantity. And then finally, diseconomies of scale take place over the region of output that's being produced where the average total cost, long-run average total cost, rises. Those are the 3 different measures of scale, all of which go back to the cost function, they go back to the production function, and they go to the computation with regard to the average total cost. Okay, economies of scale occurs when there's increasing production that allows greater specialization. More efficiency emerges. Ultimately, diseconomies of scale set in because of coordination problems, and that average total cost curve begins to rise. And that occurs typically when output levels are much higher. Okay? All right. Now we have the foundation for going on and looking at the performance of different market structures and what happens when firms compete with one another to try to capture market value. That's it for today. Thanks.